So hi guys, today I'm going to discuss all about the TCP and ARP process, TCP/IP, ARP process, encapsulation and decapsulations. So first, um, I hope you learned from what I'm going to discuss and continue to watch. So first is the TCP and IP. So for the TCP and IP, so the TCP and IP short for the transmission control. So TCP IP, it's short for the transmission control protocol. So or the internet protocol. So it is a set of rules. So this is a set of rules or protocols governing communications among all computers on the internet. So more specifically, TCP and IP dictates how informations should be packaged or turned into bundles of information called packets. So sent and receives as well as how to get get its destination. So by driving, so TCP and IP was developed in TCP and IP was developed in 1978 by and driven by and driven by Bavkan and Vent Sir. Sir. So as I said, it is a set of rules. Set of rules governing communications among all computers on the internet. So, going to highlight the important details. So, set of rules of the TCP and IP for you to be able to know and understand the most important list. So yeah. So as you can see, I have here the picture of configuration for the TCP and IP example. So as you can see, the ATM network, the server, and is connected to a one to the router. So the one is the ATM network, and then the IEEE 802 LAN to the workstation. So as I said, TCP, it is a set of rules governing communications among all on computers on the internet. So again, it's developed in 1978 by Bob Kahn and Vint Cerf. So how does TCP and IP work? So is TCP or IP is a combination of two separate protocols. So two separate protocols, which is the um, TCP and IP, of course, like what I said. So, so the Internet Protocol is standard dictates the logistic of packets. So packets sent out over a network. So it tells the packets where to go or how to get there. So for IP, it allows any computer on the internet to forward a packet to another computer. So that's one or more intervals closer to packet recipient. So the most common TCP and IP. TCP or IP protocols are the HTTP, HTTPS, and the FTP. So that's the most common TCP and IP protocols. So now let's go to the OSI. So for the OSI, so let's change the highlight to green. So for the OSI, um, so for the OSI model the OSI model, it divides the complex of task of computer to computer communication. So traditionally called internetworking into series of stage also known as layers. So layer in the OSI model are ordered from the lowest to the highest. So it layer in layers in the OSI are are ordered from the lowest to highest. So as I said, it's the lowest to highest. So um which is the in the upper layer in the upper layer it has the uh for 7 it has the application, then the presentation, then the session. And for the lower layers, it has the uh, transport and the network and the data link, and lastly the physical. So that's the ordered from low so that's the so the layer in the OSI. So that's the ordered. So in the upper layers we have the application, presentation and session, and in the lower layer we have the transport, network, data link, and physical. So it's ordered. So layers, it is the layers in the OSI. So here's the picture for the OSI. So as you can see, it is the application, presentation, session, transport, network, data link, and physical. So in the data, it has data for the application, data for the presentation, data for the session, segment for the transport, network is packets, and data link is frames, bits is for physical. So now let's go to the ARP model, ARP process. But I'm going to give you ARP process. So the ARP process. So for the ARP process, ARP process it is the address resolution itself is a two-step process, a request and a response. So it has two-step process. Okay, the request and the response. So I'm going to highlight this. So so in the so also in ARP has a ARP request. So for the ARP request, it is an ARP payload carried within the appropriate L2 header for the medium in use. So the majority of the time, this will be Ethernet, which will also be the L2 medium will be looking for. So be the L2 medium we will be looking for. So and also this has the ARP response. So the ARP response has a similar packet structure. So so and also the ARP timing. So when the ARP process completes, the information learned is stored in ARP table or ARP cache. So every device that has an IP address maintains such as table. So that's for the ARP. Let's highlight this because I'm going. I highlighted all the important. So I I have here the picture. So this the ARP table function. So as you can see, all the link the IP address and the MAC address for the different pieces. So now let's proceed to encapsulation. So encapsulations, going to put here. So in encapsulation, um, it is a process of taking data from one protocol and translate it into another protocol. So it is a process of data from one protocol and translating it into another protocol. So that's for the encapsulation. So yeah, and then so as I said, so when referring to programming, encapsulation is informations in a module or sections of codes that enables the program or programmer to use codes within a program, like that example. So and for the decapsulation, and for the decapsulation, it is a process of opening encapsulated data that are usually sent in form of packets over a communication network. So it can be literally defined as the process of opening a capsule, which is in the case refers to encapsulated or wire wrapped up data. So so it is a process of opening up encapsulated data are usually that are usually sent in the form of packets over a communication network. So that's so data is encapsulation is simple. The reverse of it is simple. The reverse of encapsulation. So this is when an incoming transmission or to be received by the destination computer is unpacked as it moves up to the protocol stack. So you can see in here, I'll provide a picture. So the encapsulation, adding header and trailer to the, so we have the header, data, and trailer. So and the encapsulations, you can see here the data, the similarities, removing header and trailer from the data. You can see in the picture. So that's all for the discussions of the TCP/IP, the iOS, TCP/IP, OSI, the ARP process, and encapsulation and decapsulation. So thank you guys for watching. I hope you learn in what I discussed, and yeah, again, thank you guys for watching.